u is equal to 5 minus x du dx is equal to minus 1, therefore du equals minus dx. So we can write this into the integral, x plus 3 over the square root of u and then minus du. So the remaining x term has to go. In order to do that, we manipulate the original substitution. So we can swap x to the other side by adding it, and then put u on the other side by subtracting it. And then add 3 to both sides so that we can get x plus 3, just like we have there. X plus 3 is equal to 8 minus u. So we've got 8 minus u over root u du. This can be simplified. Each part of the top can be separately divided by the denominator. So we would have 8u to the minus 1/2 minus u to the power of 1/2 du. Integrated, this becomes u to the power of 1/2, 8 divided by the new power of 1/2, minus u to the power of 3 over 2 divided by 3 over 2, so multiplied by 2 over 3. And this can be simplified a bit, so 16u to the power of 1/2 minus 2 over 3 u to the power of 3 over 2. U was equal to 5 minus x, so 16 multiplied by 5 minus x to the power of 1/2 minus 2/3 5 minus x to the power of 3 over 2. So example 2 is 7 over x cubed minus 4x squared plus 4x integrated with respect to x. So as the bottom of this is factorizable, we'll be able to use partial fractions to solve this. So we've got 7 over, you can factorize x straight out of this, x squared minus 4x plus 4. This can be further factorized to x bracket x minus 2 x minus 2. So, and then as this is the integrand, it needs to be rewritten in terms of partial fractions. So we'd have a over x plus b over x minus 2 plus c over x minus 2 squared. Multiplying both sides by the denominator of the left, so by x, x minus 2, and again x minus 2, gets us to 7 equals a times x minus 2 squared plus bx times x minus 2 plus cx. Let x equal 2 to 0 a lot of the terms. 7 is equal to 2c. Therefore c is equal to 7 over 2. Let x equal to 0. 7 is equal to a times by 0 minus 2 squared. So 7 equals 4a. A is equal to 7 over 4. Finally, we just need to pick another simple value of x to find b. So let x equal 1. Just out of convenience, there isn't really a strong line of reasoning for picking 1. 7 is equal to a 1 minus 2 squared plus b times 1 times 1 minus 2 plus c times 1. So a is 7 over 4. 1 minus 2 minus 1, so squared, it becomes 1. We don't need to write that. B, we don't know. And it's being multiplied by this, which turns out just to be -1. We've got minus b, and then at the end 1c, so that's 7/2. Subtracting terms over to the left side, we get 7/4 is equal to minus b, therefore b is equal to -7/4. Can set up the integral in partial fraction form now. So a was 7/4, so 7/4 of 1/x plus b, but b is negative, so negative 7/4 1/x minus 2 plus 7/2c multiplied by 1/x minus 2 squared dx. Okay, the first two parts of this, so this part and this part, are fairly simple to integrate. They just follow the ln pattern, so they become 7/4 ln x minus 7/4 ln x minus 2. The last part, taking the coefficient out of the integral, just takes a tiny bit more work. Ideally here, the denominator needs to be simplified, and we do that by letting the denominator, or the inner part of the denominator, so just x minus 2, letting that equal u. So let u equal x minus 2, therefore du dx is equal to 1, du is equal to dx. I'm just going to ditto the other parts as we work through. The only bit of this that's changing, 7/2 1/u squared du. One last change just before integrating. It's easier if it's not written as a fraction. It's easier to consider it with a power. Again, ditto, those parts come down. 7/2 u to the power of -1. When it's divided by its new power, it becomes negative. Like if you divide u to the power of -1 by -1, it becomes negative. We can put back u equals x minus 2. So this becomes 7/4 ln x minus 7/4 ln of x minus 2 minus 7/2 times by x minus 2 to the power of -1. Okay, one last example. Example 3. The integral of 3 minus 5x times by sine x dx. So there are no fractions here, so we won't be using partial fractions. One part of the integral is not related to another part of the integral by differentiation, so it's unlikely that we'll use substitution. And in fact, we definitely won't, because this also isn't a fraction that can have its denominator simplified by making it u. So u substitution is gone as an option, so we're left with integration by parts. Okay. Again, some decision still has to be made, because if we just quickly write out the rule, the integral of u dv dx, our original integral, is going to turn out to be uv minus v du dx with respect to x. So we have to decide which part of the original integral up here is u and which part of this is dv dx. if u is equal to 3 minus 5x, when we differentiate that, it just becomes a constant, which makes the whole process much simpler. It becomes minus 5. Then let dv dx equal the other part, which would be sine x, the bit of the integrand that's left over. The integral of sine x, so because we've got to integrate here, is minus cos x. And now we can assemble this side of the integral. So u is equal to 3 minus 5x, and that's being multiplied by v, which is minus cos x. From that we subtract the integral of v, which is minus cos x, du dx, which is minus 5, and then dx. It's going to be tidied up quite a bit. So we've got 5x minus 3 cos x, just taking the minus from here and distributing it across those two. Then there's minus, minus, and minus, so overall they just make a single minus, so we subtract the integral of 5 cos x dx. That integral at the back now is much easier to deal with, so we've got 5x minus 3 times by cos x minus 5 sine x plus c.